In last lecture, we were discussing about the test 1 of t-test. The heading of that is test of significance of sample mean and population mean. It is also known as one sample test for mean. Our first step in that is to set up the hypothesis. Here we have to set up two hypotheses. One is known as null hypothesis, other one is known as alternative hypothesis. In null hypothesis, always we have to write like this. There is no significant difference between sample mean and population mean. Or you can write like this: the sample has been drawn from the normal population with mean mu 0. Or h naught mu equal to mu 0. Now exactly opposite of this, but be careful. When we write h naught is mu equal to mu 0, it may possible that our claim is accepted due to this equal to sign or may be rejected due to this equal to sign. So whatever our conclusion for this equal to sign, exactly opposite conclusion regarding the claim, that we have to write in our alternative hypothesis. So in alternative hypothesis, either you have to write not equal to or greater than or less than. It's totally depends on the claim. What is the claim? Read the claim carefully. Then in h naught write equal to sign. Now according to this equal to sign, think what is the claim and what about the claim, and then exactly opposite of that you have to write in alternative hypothesis. So that we already discussed in detail in our last lecture. So now let us start next step, step 2. So step 2, here the heading of that is test statistic. Heading of that is test statistic. Step 2, test statistic. Here you have to write under h naught. Now listen, this is the most important word, under h naught. Under h naught means if your h naught having equal to sign. If your h naught having equal to sign, then and then this our next formula is valid. So always in h naught you have to write equal to sign, and whatever the sign is there, according to that your test statistics will change. But here we know that we have to write always equal to sign, so our test statistics remain same. So under h naught, the formula is x bar, that means sample mean, minus mu, that means population mean, divided by standard error of x bar, divided by standard error of x bar, where this is the symbol for standard error. So standard error of x bar, standard error of x bar. Now there is a formula. First of all, let us discuss what is standard error. So standard error is the standard deviation. Standard error is the standard deviation of sampling distribution. Standard error is the standard deviation of sampling distribution. Now the question is, what is sampling distribution? Sampling distribution means the distribution which can be generated by using all possible samples. So the distribution which can be generated by using all possible samples is known as sampling distribution. So what is sampling distribution? It is the distribution that can be generated by using all possible samples. Now the question is, what do you mean by all possible samples? So from the population, if we that we already discussed in our second year, but let us discuss once again. From the population, let us assume population having size only 10, means there are only 10 units in a population, and we want to select 3 units out of these 10 units. So how many possibilities are there? So the answer is, if it is without replacement, then number of possibilities is 10C3. That means 120 samples are possible. So write the all 120 samples. Take its let us say we want to find out the standard error of x bar. So find out the average of each sample. Average of each sample. And then find out the standard deviation of that average values. That standard deviation is known as standard error. Once again, let us discuss. First of all, how to generate sampling distribution. So let us assume our population having only 10 units. Our population having only 10 units. We want to select 3 units out of that 10 units without replacement. So how many possibilities are there? So the answer is 10C3. And if you calculate the value of 10C3, you will get 120. So 120 samples are possible. Write all that 120 samples. Each sample having 3 units. Let us take one example. Our population having 10 units like A, B, C, D, E, F, G, H, I, J. These are the 10 units. Now if I want to select 3, so it may be A, B, C possible. It may be A, B, D possible. It may be A, B, E possible. In that way, how many different possible samples are there? 120. Now first sample is A, B, C. So add A plus B plus C and divide it by 3. You will get average for first sample, average of first sample. Similarly, find out average of second sample, average of third sample. Total how many samples are there? 120. Find out average of each sample. So now you have 120 values of x bar. That 120 values of x bar, consider that is one variable and find out the standard deviation of that variable. That standard deviation is known as the standard error. Now any of you have any problem? Let us discuss first of all that one. Any problem to anybody? Any of you have any problem in this? What is standard error? Who can explain standard error? Who can explain standard error? What is standard error? Let us discuss once again. What is standard error? In one sentence you can write, standard error is the standard deviation of sampling distribution. Once again, standard error is the standard deviation of sampling distribution. This is enough statement regarding standard error. But if there is a question, what is sampling distribution? If that is the question, then you have to say like that, sampling distribution is the distribution that can be possible to generate by using all possible samples. Once again, what is sampling distribution? Sampling distribution is the distribution that can be possible to generate by using all possible samples. Now the question is, what do you mean by all possible samples? So that we already explained. Suppose in a population there are 10 observation and we want to select 3. So which 3 are possible? So maybe A, B, C possible, maybe D, E, F possible, maybe A, B, H possible. All possibilities are there. List out all that possibilities, take the average, so you will get sampling distribution of x bar. It is known as sampling distribution of x bar. And now find out its standard deviation. That standard deviation is known as sampling standard error. That is known as standard error. Now once again, who will explain regarding standard error? Roll number 125. Roll number 125.
Sir, may I?
Sir,
Yeah, you. Yes, yes, yes.
Standard error is the standard deviation of sampling distribution.
Perfect. Standard error is the standard deviation of sampling distribution. Now, what is sampling distribution?
The distribution which can be generated by using all possible sample is known as sampling distribution.
Very good. How can you obtain the all possible samples?
Sir, if we want 3 units, all सर तब में से अपन को अगर 3 यूनिट चाहिए 10 यूनिट है और तो फिर 10C3 वो यूज करके 120 यूनिट रिजल्ट हमको मिल सकते हैं.
Perfect. Very good. Very good. Okay. Let us continue now. Let us continue. So, there is a formula of standard error. That first of all you have to find out standard error by using this formula, standard error of x bar. There are two formula. Either use this formula, s divided by root n. Another formula is s divided by root n minus 1. Both are valid formula, but listen carefully. Here s, to calculate s, you have to use this formula. Root of sigma xi minus x bar the whole square upon n minus 1. This is the formula of s if you want to use this formula for standard error of x bar. And instead of this, in some of the book, the formula of standard error is this. But in that book, the formula of s is different. So, both are valid formula for S. Now the question is, this is standard deviation, this is also standard deviation. For sample, S is a standard deviation of sample. Now the question is, why there are two formula of S? Why there are two formula of S? So, this S is the unbiased estimator of standard deviation of population, that means sigma. So here S is the unbiased estimator of sigma, whereas here S is the biased estimator. Biased estimator of sigma. So one is unbiased estimator, other one is the biased estimator. The concept regarding unbiased estimator and biased estimator, that is the point of estimation. There are two use of sample, one for estimation and other for testing. There are two use of sample, one for estimation and the other for testing. Right now we are discussing about testing, but in chapter estimation theory, in the topic estimation theory, it is clearly mentioned that if you use this, means it is already proven that if you use this formula, then it becomes unbiased estimator, and if you use this formula, then it becomes biased estimator. If you want to study in detail regarding bias and unbiased, you require to study one another topic that is known as theory of estimation, which is beyond of our syllabus right now. So just learn this, and we are using this second formula now onwards for standard error, this second formula. So for uh, standard error of x bar, now onwards we are going to use this formula where our S is bias estimator. The reason is, if we use this formula, our calculation becomes more simple compared to this formula, because simplification is here easy. See, another formula of that is root sigma xi square upon n minus sigma xi upon n the whole square. So either you can use this formula or this formula, you will get the same answer, and this is more simple in for calculation point of view. That is why we are going to use this formula now onwards. That is why we are using this formula of standard error, not this first one, the second one. So now onwards we are going to use this formula. Listen carefully. So use this formula, second formula, as a formula of standard of x bar. So your formula of t becomes now our formula of t becomes x bar minus mu upon standard error, that means s divided by root n minus 1. If you use this formula, then your formula of t becomes like this: x bar minus mu upon s upon root n. In some of the book you will find this formula. We are going to use this second formula, and if you simplify, then it becomes like this: x bar minus mu into root n minus 1 upon s. So this is the formula of t. Now onwards, once again we are going to use this formula, this second formula. This is our main formula. So for this question, for question number 5, how to calculate this t? Just tell me how to calculate this t. 2.49. How to calculate this t? Our formula is this: x bar minus mu into root n minus 1 upon s, where s is a standard deviation. Once again, what is s here? Root sigma xi minus x bar the whole square upon n, or another formula, root sigma xi square upon n minus sigma xi upon n the whole square. You can use any of these two formula. Okay, who can tell me how to calculate value of t 2.49 by using this by using this information? Question number 5. See, the question is, an automatic
Uh,
machine. Yes.
वी कैन सर हम एक्स बार फाइंड कर लेंगे सैंपल मीन और पॉपुलेशन मीन दिया हुआ है और फिर स्टैंडर्ड डेविएशन फाइंड करेंगे कैपिटल एस.
Wait. How to calculate sample mean?
ये सैंपल्स दिए तो है, उसके ऊपर से अर्थमेटिक में निकाल लेंगे.
So 168.3. How can you calculate 168.3?
ये जो 10 सैंपल्स है उसका अर्थमेटिक मीन निकाल लेंगे.
कौन से 10 सैंपल से?
168, 164, 166, 167 to 170.
उसका क्या करोगे?
अर्थमेटिक में निकालेंगे.
कैसे
अर्थमेटिक
निकालोगे?
मीन
कैसे
सिंपल
निकालोगे?
समेशन ऑफ xi डिवाइड बाय n.
Very good. So just add all this 10 observation divided by 10, you will get x bar. Perfect. Okay. Now we want to calculate t. So here we have x bar. What is mu?
170.
Very good. Mu is 170. Perfect. What is your n? What is your n?
10.
Perfect. So n is 10. So 10 minus 1, that is what? 9. Root of 9, that is what? 3. So this is 3. X bar is known, mu is known. So x bar minus mu, that is also simple calculation. Into 3, we get numerator. Now the question is how to calculate s.
सिंपल स्टैंडर्ड डेविएशन की कैलकुलेशन से.
करेक्ट, स्टैंडर्ड डिविएशन की फॉर्मूला. सो स्टैंडर्ड डिविएशन की फॉर्मूला कौन से लगाओगे? आइदर यू कैन यूज दिस फॉर्मूला और दिस फॉर्मूला, नो प्रॉब्लम, यू विल गेट द आंसर. So calculate all these values and put all values in our formula. We get value of t. So by using this, let us say this is equation 1. So by using equation 1, we get value of t, which is known as calculated value of t. Calculated value of t. We get calculated value of t, and that is why, which is denoted by t cal. So t cal is the symbol for calculated value of t, and to calculate that value you have to use this formula. So now you can say that this value 2.49, that is which value? So the answer is calculated value of t. 2.49, that is the calculated value of t. So in step 2, by using this equation 1, we have to find out the calculated value of t. That means we have to calculate t cal. We have to find out t cal. And here one more step you have to write, one more sentence you have to write. Here, degree of freedom, which is denoted by df. Degree of freedom, the symbol of that is, actually the symbol is mu, but you can write v. You loosely speaking you can say it is a v. Actually it is not v, it is a Greek letter, and it is nu, that is the pronunciation, but you can say it is a v. So degree of freedom, df, the formula of that is n minus 1. Just you have to learn this. Degree of freedom is n minus 1. Now the question is, what is degree of freedom? So the formula, the definition of that is, degree of freedom is the number of independent observations. Number of independent observations, that is the definition of degree of freedom. So if anybody says what is degree of freedom, then you have to say like this: degree of freedom is the number of independent observations. What is degree of freedom? So answer is, degree of freedom is the number of independent observations. Now the question is, what is independent observations? What is independent observation? What do you mean by independent observations? So to get the idea about that, let us take one small example. If I say that, give me a 5 numbers, any 5 numbers, give me any 5 numbers. So you can say that it is very simple. 5 numbers are 49, 29.2, minus 5724, 229, minus 0.1. Okay, that is nothing wrong in it. These are the 5 numbers. So all 5 numbers are independent. You can say any 5 numbers, because what is your question? Give me a 5 numbers, nothing else. But now if I put one condition on that, let us say the condition is, give me a 5 numbers, so that if I add that 5 numbers, then I will get 100. Means tell me 5 numbers so that their sum is 100. Tell me 5 numbers so that their sum is 100. So you can say that. That is also very simple. You can speak any of 5 numbers. Let us say 44 minus 1083, 0.44. 2507. Now the last number you have to say in such a way that if we add remaining, if we add all that 5 numbers, our answer should be 100. So your last number, it depends on these 4 numbers. You can't say any number because there is one condition. What is the condition? Total should be 100. That is a condition. So you are free to say any of the 4 numbers except the last one, because there is one condition. Because of that condition, your number of independent observations are not 5 but it is 4. So now listen, every time the formula for degree of freedom is not fixed n minus 1, it's change, depends on the situation. Right now my situation is find 5 numbers so that sum is 100. If I add more conditions like find 5 numbers so that sum is 100 and sum of squares, sum is 100 and sum of square is 5000. So now there are 2 conditions. First condition, sum should be 100. Second condition, sum of square is 5000. To satisfy these 2 conditions, you are free for 3 observations, and 2 observations are depends on that, because there are 2 restrictions here. So independent observations are 3 and dependent observations are 2. So degree of freedom is 3. N minus 2 is the formula because of 2 conditions. So every time it will be changed. But right now for this particular question or this particular test, you have to learn that degree of freedom in this test is n minus 1. Okay, now once again, what is degree of freedom? Who will answer? What is degree of freedom?
Number of independent variate which make up the statistic.
Once again,
number of independent variable which make the statistic.
Okay, instead of word variable, better word is observations.
Observation, okay.
Yes, you are right. Okay, so the formula for this is n minus 1, and that is, you can say that end of step 2. Now step 3. In step 3, you have to write only one sentence, that is level of significance. Level of significance, it is denoted by alpha. Alpha is
Sir,
the level of significance. And
sir,
yes,
सर ये डिग्री ऑफ फ्रीडम में n-1 टी स्टैटिस्टिक में मुझे समझ में नहीं आया.
बस वो just you have to learn right now this one. In first test of T, you have to consider degree of freedom is n minus 1. Why it is n minus 1? There is one reason here. There is a restriction about, we are discussing about the one sample and we are discussing about the population mean. So population mean is known, that is the condition.
Oh, okay, understood.
That is, it is n minus 1 here.
Okay.
Okay, now level of significance. So if nothing is mentioned regarding level of significance in the question, then you have to write level of significance alpha equal to 5% over level of significance alpha equal to 5%. In some of the books, it is also written as 1%. So level of significant alpha is either you can take 5% or 1%. That is not, whenever nothing is mentioned in the question, you have to take alpha equal to 5% or 1%. But now the question is, what is level of significance? So you can say that level of significance is the probability of type 1 error. What is level of significance? Once again, level of significance is the probability of type 1 error. Now the question is, what is type 1 error and what is type 2 error? There are two type of error, type 1 error and type 2 error. What is type 1 error? Type 1 error. And what is alpha? So alpha equal to probability of type 1 error. What is type 1 error? Yes, any of you know what is type 1 error?
Yes, sir.
Yes, please.
Reject null hypothesis when it is true.
Reject null hypothesis when it is true. Correct, you are absolutely right. This is type 1 error. Reject H naught when it is true. That is type 1 error. And whatever the probability of type 1 error, that is known as level of significance. Whatever the probability of type 1 error, that is known as level of significance. Now, what is type 1 error and type 2 error? That is you have to find out. We will discuss that in our next lecture in detail. It is there in our, you have to read this. We will discuss in detail about this type 1 error and type 2 error. You have to explain that. See, this is type 1 error, type 2 error. So you have to explain me detail regarding type 1 error and type 2 error in our next lecture. That is you consider as your homework. So this is enough for today. If you have any question, we will discuss in our next lecture only.